Hello, everyone. This is Scott Schweitzer. Welcome to SmartNix today. We've got Xelera with us, a good friend of mine,
Ron Renwick.
Ron and I have known each other for dozens of years.
I don't want to tell you the number.
So Ron will be co-hosting with me today. Ron, why don't you introduce yourself?
My name's Ron. I run a small consulting company doing go-to-market and product marketing for mainly networking startups. Scott and I have known each other since Scott was running product management back at Miracom, I think, right?
Yep.
We've done high-performance networking. Our latest overlap was high-performance FPGA space, working networking. Scott running product management, me running product marketing. We tend to think quite alike, and happy to be able to talk with you again, man.
Hey, well, thanks for helping me host out today. We have Felix Winterstein, CEO of Xelera, and Andrea Suardi, head of acceleration technology. So thanks for joining us today, guys. Felix, why don't you introduce yourself, and then Andrea, you can introduce yourself.
Thanks for hosting us, Scott. So very happy to be here. Today I'm the CEO and also one of the co-founders of Xelera. I have an engineering background, and we've been around with Xelera for quite some years now. Been following your publications, Scott, your articles, posts, blogs on LinkedIn, and I think first time I met you was in 2023 at the SmartNix Summit. So very happy that we're getting closer here.
Thank you. Thrilled to have you guys on today. Andrea, how about you introduce yourself real quick?
I'm Andrea. I'm also the co-founder of Xelera together with Felix. My background is engineering, specifically FPGA engineering. I started around 20 years ago on this field, tried to optimize algorithm on FPGA platform to achieve low latency and low power consumption.
Excellent. Everybody loves a good origin story. So, Felix, my understanding is you and Andrea met each other at the Imperial College in London while you were doing some deep research into FPGAs, working on digital computation, high-level synthesis, in the Imperial Circuits and Systems group, while Andrea was researching FPGA-based implementations for control systems. Do you want to give us a little background on that and how you guys came together?
Yeah, sure. So FPGA technology is a bit special in the sense that it has the ability to not let people go anymore, right? So many people I know who started once working with FPGAs on that technology are sticking with it for many, many years. It's really an interesting observation. And so the same thing actually happened to us, right? So we've been together at Imperial College London, and that is a while ago, Andrea. I think first time we met was probably 14 years ago, I believe. So we were both working in the research group there, which had a strong focus on FPGA technology, where it was more about developing, mathematical tools, algorithms around it. Andrea was working control. 2015, I believe, we were stage where we were looking for what to do next. With myself about to finish my PhD and Andrea, I think, being some time into postdoc position. And, it's this time when you think, okay, what's next? And there's a few options. And that was the time when Intel acquired Altera and gave the FPGA field a lot of new, fresh wind and also a new direction, which was data center. Right. So that was the new thing that time that came up. And then I think shortly after that, there were all these things following that. AWS introduced FPGAs in the cloud, and also Xilinx jumped on the data center space. So there was a lot of new ideas, new applications actually coming around, and this was the point where we thought, okay, so there's this new field for FPGAs, right? So before you had FPGAs in the traditional areas like embedded systems. There was actually some big portion of that in networking already, but I think the data center with all its different potential applications and use cases was something very new. I think new to everyone, and everyone, including the big companies, needed to figure out what is the fit between that technology and use cases and applications in the data center, which is a very interesting time. And we thought, first of all, things are moving, and that's the best thing if you're just about thinking to start something new. It kind of was a good coincidence. And the second thing is that there was a lot of traditional applications that used to be like the number one applications on FPGA platforms were not the ones that you were looking for in the data center, right? So there's a lot of questions around what applications are these, what kind of infrastructures do you need, what kind of tools do you need. All of that was new questions that I think interested us a lot, and that was the starting point for us to get on this journey, which actually a bit later, so 2 years later or something, turned out into something that we call Xelera today. So it kind of was an interesting development, and we found our way through. And that was a time when there were a lot of other companies and startups being founded in that space. So yeah.
Yeah, FPGAs are definitely very sticky, and I started experiencing them myself back in 2016, 2017 as they showed up in high frequency trading. What is this computational platform called an FPGA, and why is it so mystic? It seems like it's not programming, but it's not electrical engineering. It's kind of somewhere in between.
It's a lot of fun at the same time, right? So once you get your hands on that technology, it's really, you don't really know why, but it's kind of fascinating, and it's really fun to work with it.
It's almost going back to the early days of computing when we were writing an assembly language and hooking up logic gates to, our small processors, trying to make it all go.
Yeah, I remember back to my undergrad days where we were programming programmable logic controllers to do very simple gate things, very simple control systems automation thing. And now coming into this space where FPGAs are accelerating high value applications is very different. And I've been around Xelera for a little bit, helping you guys out. I know you do two things. You essentially do network acceleration, you do security, machine learning, inference. So for someone who is not a hardware engineer for a customer, because a lot of people think when they hear the word FPGA, they freak out. They think, well, I don't want to program. I don't know HLS. I don't know these capabilities. So what is Xelera? Like, what do you do? How do you explain what the company does to an end customer? And do you abstract away the FPGA portion? What is Xelera?
Yeah, so that's actually a very good question. So coming back to the end of your question, I think there's not really a point in trying to pitch FPGA technology to many of our customers. It does not matter whether this is an FPGA or whether this is some other type of platform. That is actually not the point. It's of course always important what is the thing it can deliver, and that makes a difference. Now, in order to explain someone who is not a hardware engineer and what we do and why this matters, I mean, our home turf is data center, right? So the network acceleration we do is data center focused, and also the AI inference accelerator on FPGA technology is ultimately running in data centers or in co-location data centers. So about the data center, it's still, about the networking part, it's a very interesting times, right? So we are currently seeing massively pushed by AI infrastructure, of course. We are seeing a massive build out of data center capacity. So if you look at analyst numbers, there's different numbers around, but we are expecting a 3x to 5x capacity build out of global data center resources in the next 5 years, which is huge. And there's different challenges. There's, of course, the number one KPI is compute capacity, and that's where companies like NVIDIA are very well positioned in, driving that market and satisfying that demand with GPU technology. The other area that is actually not so common is the data center network itself. And if you look at numbers you find by IDC or other analyst firms, you see an exponential growth of the amount of data we are pushing onto our data center networks today, right? So, and it's a very abstract number, but think of it like you were doubling the number of cars on the highway from Menlo Park to San Francisco, right? from one year to another. Just imagine the challenges that causes, right? And that is actually what we are experiencing today in the data center networks. And that is causing a lot of interesting problems. One being that all these cars or in the network is all these packets need processing for different reasons, right? Network security, whatever. And all that processing at that speed and that growing speed is reaching its, or the traditional way of doing that, processing that alongside the application on the server, is actually reaching its limits, right? So as we double the bandwidth every year, almost servers are not doubling their compute capacity every year. So that's actually a problem that is appearing in some applications like AI infrastructure today very heavily already. In other applications like cybersecurity and network, we are seeing it becoming a pain point, and it will definitely become a problem that must be solved in the future for many more applications. So this is, I think, the thing that every infrastructure buyer, architect, network engineer needs to consider, right? And that is something very independent of an FPGA.
Oh, sorry, I didn't mean to interrupt you. I meant just to flag you, because I was going to ask you, what are the products that Xelera provides to customers? And can you give us a specific breakdown on what the products are and who they address?
Yeah, so we're providing two product lines today, as you say. So one of them is in the network acceleration space. So this is a classical DPU product, which is a software layer on top of third-party hardware platforms available. So we're not providing our own chip. We're using existing hardware like FPGA-based platforms for offloading like classical DPU use cases onto these accelerators. We have a strong footprint in the cybersecurity vertical where we offload network security functions like layer 3 encryption and IPsec, firewall applications and things like this. So this is one product line doing that at speed grades from 100 to 400 gigabits today. And the second application, the second product line is where Andrea is heading the product ownership, is the AI acceleration tuned for latency. So AI model inference acceleration optimized specifically for cutting the inference latency per query to a minimum.
So let's bring Andrea into the discussion now. Andrea, you've been a regular at the STAC Summit, STAC Research's events that they hold both in the spring and the fall, New York, London, Sydney, etc. And I think you had a talk recently, deterministic ultra-low latency inference for gradient-boosted trees and trading. And that's kind of been around through the events. Why don't you give us a little bit of background on that and how that fits into the space?
Yeah, absolutely. So first of all, for who doesn't know what STAC is, right? STAC is a security technology analyst center. So at the end, is a community, is a network where financial institutions, as example, quant funds, investment banks, or market maker, and also technology provider are gathered together and run some benchmark, evaluating the technology used in trading infrastructure, right? So when you attend these type of events, you get in a room really deeply technical people. So you have quant developers, low latency engineers, heads of trading technology who really cares about numbers. There are no people from marketing here, right? And all these people are trying to solve one simple problem. They would like to optimize their execution stack. So cut every nanoseconds from their stack. And the reason is, if you have read the book of Flash Boys from Michael Lewis, right? This explains exactly what's going on there, right? So you need to
that's
be
a great book, by the way.
Possible.
If others haven't read it, you probably should. Very interesting. Yeah. Sorry, Andrea. Go ahead.
No worries. So you need to, in order to reduce, you need to cut the latency, and this is automatically transforming, increasing your profit in your trade, right? There is a catch. You cannot go fast, but always fast. You cannot go fast one time and another time be very slow. Just to give you a rule of thumb, if fast is 2 microseconds and you go fast 99 times, and one time you go 200 microseconds, that is not good for them, because this means you are adding a tail latency spike. And doing a trade with these massive spikes, you can lose because you arrive later compared to another trading firms. And what the trading firms do, in this case, they prefer, speaking with some traders, they say, if I'm too late, I prefer not to trade and wait.
So Andrea, a couple of things, and you talked about it has to go fast all the time. What does that mean? I was on a project a while ago with network flows serving pictures only, okay, for a hyperscaler. And the main thing they were worried about is how most of the images they served had to get through in a specific time frame, because when something lags, people get frustrated. That's a very personal and emotional thing. How does that work in the trading world? What is the lag capability? What is the spread essentially on the latency? And then taking that a little bit further, we talk about microseconds of delay. And with a gradient boosting model, you can deliver inference in a single digit microsecond. But what does that mean in practice? Do you know how much money people can lose or make, or what the challenges are, basically, if it's a microsecond and if there's too much lag in that microsecond measurement?
It's a really good question. And the real answer is a secret of each trading firm, right? Each trading firm build their own model they call P&L, profit and loss model, to map the market to see how their trading strategy, how much they gain at a certain latency, given a certain latency, right? This is very difficult to build because it depends what you trade, where you trade, and which strategy you're building. But just a rule of thumb is if you are too slow, as I was saying earlier, if you are running 200 microseconds, you are probably a price taker. You are not a price maker. So you would like to be the first in line when you do a trade, not be the last one. And that's actually what all of is about. The book I was saying earlier, right? The Flash Boy, optimizing toward the speed. You can use a very simple trading strategy, as example, an order flow balancing imbalance. But if you are faster, you can win. It's important to win just 50.001% of the time, and you are the winner of the game, right? That's just a small gap. But what we are observing today is a little bit of shift. There's still there a little bit of going faster as much as possible, but now trading firms, they would like to be faster and smarter. What does it mean? It means that instead of having a simple algorithm to do a forecast, can be a simple linear regression algorithm as example, right? They would like to use more complex algorithms such as machine learning and the gradient boosting that you were citing before, right? This type of algorithm allow you to capture better the dynamics of the market, the microstructure of the market. Look into the past, they can forecast the future, right? Better. So, but as soon as you are trying to use a more complex algorithm such as gradient boosting, the amount of compute behind compared to a linear algorithm, as example, is increasing exponentially. And this translates in latency. So at the end, you see on one side, you have a smarter algorithm that can do better forecast, and on the other side, this algorithm is too slow. So there is a sort of trade-off, right? And that's the challenge that most of the trading firms are facing today. And actually, let me tell a story. And that is about when we started with the Xelera Silva product. We used to have, back in 2020, when we after started the company, to have a product that does run inference on general random forest algorithm. And the use case was quite general for, let's say, data center workload with big batches, so where throughput was mainly important, right? At one point, and we were not aware of the high frequency trading, let's say, use case. At one point, a company from China actually can contact us, right, and say, look, this was back in 2022. We built a great model in our let's say, data scientist in quant, a great model in gradient boosting. But when we run it on a CPU, we just take around 50 microseconds, right? And we like to use it, but we lose all the money when using this model, even if the forecast was better. And they ask, can you make it run faster with your product that you already have? Our product back then was tailored for throughput. And we update the product to be more tailored for latency. And we have been able to ship to them an inference just running in 5 microseconds. So they went down from 50 to 5 microseconds at an X improvement, right? And this is how we achieve it. We just offload it to an FPGA card. And what's happened? Giving back the latency, they got back the profit that were losing running the inference using a CPU as example. And that's where Silva, the Xelera Silva product, jump in. We are solving the latency issue that have these high-frequency trading firms. So we provide the engine to run fast. They put the fuel. The fuel is the algorithm. They train their model.
Let's expand on that a little bit, Andrea. I mean, HFT obviously is the headline use case, but it's not the only one. You can use Silva in other real-time domains like cybersecurity or DDoS or things like that. Can you walk us through what it might look like in practice in these other markets or other use cases? And what decisions is Silva actually making inside the network data path from a security context point of view, and how do these algorithms actually fit into the decision-making process?
Yes, actually, this is a good point. So you can think about in cybersecurity Silva as a security guard that's standing at the front door of your network. So every piece of data coming in from your network can be processed in real time, so at line rate. And you can make a decision if this packet is good or bad before even the packet reach the server, right? And that's where the Xelera Silva product fit inside the smart FPGA-based Markets solution that Felix was telling, earlier. And we have two use cases here. One is the ransomware as example. So if you have a ransomware attack, before you start encrypting all the files on your disk, the ransomware start communicating with a closer network device, right? And we can detect in real time this traffic anomaly with a closer server. And that is done at a line rate, and we can stop the ransomware acting. We can stop the ransomware before it starts encrypting all your files. Or, as example, the DDoS attack. So in the DDoS attack, you have thousands of packets flooding your network. But how can you distinguish if these are genuine, thousands of packets coming in because there are a lot of users using your, as example, server, or it's a DDoS attack? So there are some patterns that can be detected. And all of these two use cases actually map really well to gradient boosting algorithm, which, as I said earlier, like in the high-frequency trading use case, they are really good to detect patterns, and that's what you would like to see in the network. So how we deploy? So we provide the same IP that we use in high-frequency trading. We put inside our FPGA's Markets directly connected to the net. At line rate, we can, and this is throughput, we support the throughput of the line rate, we can detect the packet. Now, as I said earlier as well, we provide the engine. We don't provide the model. Actually, the model can be loaded on the fly. And this is very important for this use case, like also in finance, because the model, the weights can be changed. They can change based on the time of the day, maybe on the use case. So it can be loaded on the fly without reprogramming a new, let's say, FPGA.
Andrea, I find that people love numbers in terms of understanding what can I do with a product. With networking, can I do 100 gig or 400 gig? People get that throughput number. With something like Silva, are there a number of concurrent algorithms? Is there a file size? Is there something that a customer could say, oh, I've got 2 million weights that I'm trying to calculate simultaneously? Is there something that can tell somebody what the capacity is of Silva on an FPGA?
Yeah, before giving you some numbers, some concrete example, right, some benchmark that we run, let me explain. Silva actually can be deployed in different modes. We have two main modes of deployment. The first one, what we call the offload mode. So we provide a full solution where it consists of a FPGA stream, driver, up to an API, and the user just can be a data scientist or a plain software engineer, can just call it inference via an API in those systems. So when you call inference, you send data through PCI, you do the compute, and you get back the results, right? And when running an offload mode, you can offload in all the compute to an FPGA. You can handle very big models. As example, models of, if you're speaking about a big model in gradient boosting, you are around 1 million nodes. gradient boosting model with around 1 million nodes. Or if you're speaking about neural networks, you're speaking about network with more than 1 million weights, as example. And if you try to run inference on a standard framework, running on CPU, as example, on gradient boosting, this big model, you take around 30 microseconds. Instead, if you flow to an FPGA, accounting also the PCI cost of moving data, you're around 1 microsecond. This is the scale of difference. So you're around 30x faster running on an FPGA compared to CPU. That's for gradient boosting, which is, let's say, not optimal algorithm for CPU because it's really, it's not optimal algorithm for CPU. But if you look at LSTM as example, a neural network, it is widely used even in high frequency trading. If you write it on CPU, this 1 million parameter model, you're around almost 1 millisecond. Instead, if you offload to the FPGA with the parallelism that is inside FPGA, you get around 3 microseconds. And that's the order of magnitude difference in speed. And that's when we consider the offload mode. But we have not stopped there, actually. When you offload, you need to pay price, that is moving data over PCI. And because we are speaking about single-digit microsecond latency, you can have in mind that just moving data back and forth PCI, you're around 500, 600, 700 nanoseconds. It depends on the packet size, right? So you're paying a big cost moving data. And that's where the second deployment mode that we have, which we call the inline mode. So that's the use case of that spoken earlier of the cybersecurity inside the SmartNIC, or even in high frequency trading for the people who do tick-to trade. So where everything, the data is coming in through the network inside the FPGA, they do all the compute and they go out from the network to FPGA. No CPU is involved. And here latency is very important. You don't cross anymore the PCI bus, so you can save latency, and the total latency will be in the order of a few hundred nanoseconds here.
So given those numbers, are there specific use cases like colo where people maybe can't spec their hardware? Are there specific environments where customers need to run on a CPU or have to run on FPGA or something like that?
Yeah, if you look the high frequency trading use case, most of the people they have their own server in a colocation environment, right? So they decide which server to buy, they overclock server, they decide which card to put in, and that's where FPGA actually are widely used. But there are also other use cases in high frequency trading, and actually is quite a new one. I'm speaking about the crypto case, where if you look at crypto exchange, is running on the cloud. So they don't have access to the FPGA. Yes, actually, if you look at AWS, as Felix said earlier when we started Xelera, there are FPGA instances. There is also on Azure FPGA instances. But to get lower latency, you need to optimize the full stack. It's not just running the inference. You also need to optimize how you transfer data over PCI. And unfortunately, in the cloud, you cannot touch the PCI, and you're going to pay a high price. And that's where CPU comes in, actually. I said some number earlier that big size gradient boosting is around 30 microseconds latency, right? That is when you use on a CPU, a high-end CPU, using a standard of the shelf framework, libraries that are already available, right? But these libraries are quite general purpose, not designed for low latency. What we did at Xelera, we did a step further, actually. We have rewritten these libraries with one goal in mind, latency. Our challenge was, can we write a CPU kernel function which run faster than off-the-shelf library? And that's what we achieve. It's quite interesting. As example, if you take the gradient boosting algorithm, if the model is small enough to fit the CPU cache, you can actually achieve sub-microsecond latency because we are not paying the PCI cost. But as soon the model is growing inside and overflowing the cache, the CPU is becoming slower than the counterpart FPGA accelerator. And that is for gradient boosting. If you look instead LSTM model, where the main compute is a matrix vector operation, right? You can leverage latest, let's say, Intel CPU MX instruction as an example to run inference. And you can bring inference back from using a standard framework that I said earlier, 500 microseconds down to 50 microseconds only, right? That is the advantage that you can get if you really write a kernel optimized for latency. So the reason why, to wrap up, the reason why we have introduced Xelera Silva is to extend the use case of the product, and mostly for people who doesn't want to use or cannot use an FPGA, they can start experiencing inference at low latency.
Felix, let's pull you back into the discussion here. Most people think of SmartNICs as cards that move packets faster and they free up CPU cycles. The classic pitch is that, infrastructure tasks consume 30% of CPU cycles in a server to service data center workloads, and the SmartNIC can remove that burden and have that execute within the NIC itself. Can you expand on some of this and explain how what you have offers a different advantage?
Yeah, so the 30% tax rule that you cited is the offload case, right? So that's obviously one very big value proposition of SmartNICs to offload the server from the burden of packet processing. While there are other use cases and other value propositions of SmartNICs, if you execute some functions like packet processing or even AI-based decision-making directly on the SmartNIC, offloading is one thing. The other thing is that you are getting your hands on the data before it even touches the server. And this is something that has different implications according to what type of application you're looking for, right? So if you are in a context of a DDoS, like next generation denial of service detection use case that Andrea mentioned, you will actually have the chance to have a higher level of robustness and protection because you are able to execute and prevent a DDoS attack, for example, through anomaly detection with an AI model, even directly in the network card before any data, any packet touches the server. So that is providing like a massively increased robustness for such a system. In an application context, like we have, for example, in high-speed decision making in HFT in trading, which is one of the primary use cases of Silva, we have the ability of making or saving a lot of latency. So that's the kind of latency that Andrea mentioned already. If we can avoid sending the packet arriving from the network over the PCIe bus, having it handled by the driver and all these things, we can actually save that latency, and that is a substantial amount. That's actually several hundreds of nanoseconds latency at least that's saved there, which is relevant in super high critical low latency applications. So these are like more functional and performance related benefit that you get from executing a function or decision making directly on the network card.
So Felix, when you're talking to potential customers and they're interested in evaluating Silva, who are you actually talking to? Who's in the room? Is this network security guy? Is this the network architect, C-suite? Who shows the initial interest and how does that progress?
Yeah, so actually it is often all three of them. Network architect is clearly, in use cases where there's network security or some challenges that some of our customers see with when they upgrade to the next speed grade with their system, right? Going from anything below 100 gig to 100 gig or 100 gig to higher than that. And they see challenges with the traditional way of how packet processing was done. We talk to architects, right? We talk to network security architect. We talk to the engineering team. Typically, that is very early on the point of contact for us. C-suite, I think, is usually not involved in these conversations. That's more like the starting point of the conversations at some point. But yeah, so we are. I think it's like a really diverse type of personalities we talk to there depending on the application and the problem they're trying to solve.
Let me take it back a little bit because I think that's the network security side. Who do you talk to from a Silva perspective?
Yeah. Silva is typically, I mean, the demand for cutting latency is typically something that is originally articulated by the quant team, right? Because the latency is part of the equation if a trading strategy can be successful or not. And so that's typically coming from like the origin of the developer of the strategy, which is usually the quant team. And we either talk to quants directly or they pass it on before that to like their infrastructure architects, their infrastructure teams or engineering teams that are supposed to, solve these latency effects. And that is usually our point of contact for Silva.
Where do you see Xelera going? Obviously, you're finding new opportunities in HFT. You're increasing speed loads. But where do you see the company evolving into, and how do you see that kind of shaking out over the next couple of years?
Yeah, so Andrea, we can probably split that with respect to Silva and the network acceleration part. I can start with the network one. So we do see, I mean, we have clearly today cybersecurity, network security is one of our key verticals for the SmartNIC use case. Roadmap here on a technical level is actually, on a product level is actually we are going to announce very soon officially, we are doing it now here in the podcast, that there will be the transition to 400 gigabit, which we've been working on internally for quite some while and have been testing that. And it's now going to come out near term. So that is actually putting two things to the equation here. First of all, there is an extension of the product in the network security workspace, and the other avenue this opens is actually AI factories, which have, again, very interesting networking problems. And it's not like network security functions, but it's other types of protocols, clever ways of DMAing directly from network into accelerator, AI accelerator memory and the related protocols this involves. So this is one of the avenue that an increased speed rate like 400 gigabit plus is opening up, because that is the type of speed we're talking about in neoclouds and AI factories. So this is like, from a network perspective, is one of our near to mid-term roadmap items. And then we've got a couple of exciting things coming up on the Silva side, which Andrea can comment on.
Yeah, on Silva, we just launched the CPU only version, so to run Silva only on CPU, with the idea to expand to broad the audience, not just in high frequency trading, which we've been working in this field for the last, let's say, 4 years, but it's really a niche market. So what we see beyond HFT trading, there are a lot of use cases on the embedded AI, where you can deploy AI model directly at the edge. So that will be the next, let's say, use case we are going to look at. But at the same time, we're also planning to extend the algorithm support. Today, we support 2 classes of machine learning models, gradient boosted tree, and a variety of neural network from LSTM, MLPs, other recurrent neural network. We plan to move a bit more complex model from transformer up to, let's say, LLM in general. Let's see, because we see demand. There are people around already working. Sorry, let's stop it. There is the market in large language model inference is a little bit booming right now, because the cost of running inference is exploding. So there is a race to provide solution which run fast, but at the same time consume a small amount of energy. And that is an area where it makes sense that what we are doing today, we can expand it and try to grab a little bit of this market.
So Felix and Andrea, if I were to ask, what's the one thing people should remember about Xelera following this podcast, what would be the one thing you'd want them to have stick in their mind? And if you could just kind of keep it short and sweet, that'd be great. Felix, why don't you go first?
Yeah, so I think that one of the key points is really that there's a lot of different types of SmartNIC and DPU use cases, right? And it's a very tricky space. We've seen that there are clearly gaps and, architectural shortcomings with architectures of the established, well-known players. And that is actually one of the key points why we see a lot of business. I think the SmartNIC DPU cases are quite diverse across different customers, across different use cases. And I think the way of being able to adapt and fine-tune to these small specificities is one of the key things that we offer with good success for the last couple of years to our customers. And I think that's really what we enjoy and we like to continue.
Andrea, how about you?
Yeah, one thing to remember about Xelera is we're offering in both cases the AI inference or the FPGA-based SmartNIC. We offer a full solution. So you don't need to be scared about FPGAs, and you don't need to be an FPGA expert to use our product or a SmartNIC expert. We abstract everything away to make your life, the customer life, easier. Also the integration easier. This is what we are doing.
Ron, do you have any closing statements or words you want to make?
I don't. I love how Andrea closed it out, saying we're trying to make your life easier.
There you go. Sounds like a corporate slogan. Xelera, trying to make your life easier. Trying to make FPGAs easier for people to understand and use. Ron, Felix, Andrea, thank you very much for your time today. And I appreciate you talking with us. And I wish Xelera all the best.
Yeah, that's good.